Hello and welcome to this presentation on using images in GeoGebra and building an interactive trig worksheet. In this presentation, I'm going to take you through a step-by-step process for creating an interactive GeoGebra worksheet. The worksheet is going to provide students with an interactive application problem and where they can change the parameters and have different configurations and solve the problem multiple times. As I take you through this tutorial, you will learn how to insert slider tools and attach them to objects in the workspace, a checkbox to show the answer and hide the answer, and include images such as this hot air balloon and this observer, and attach them to geometric objects. Now, as I walk you through this tutorial, I think you'll get an exposure to a lot of GeoGebra's capabilities, and I'll share with you my techniques for creating some of these objects, and hopefully you'll develop your own along the way. And I'm going to do this in an imperfect way so that we get to experience how to go back and modify something later in the setup, because often when we're building things, our ideas change on the fly, so we should be able to, or at least learn how to go back and modify something and not feel like we have to start from scratch. So before we get started with the tutorial, here is a live look at what the GeoGebra worksheet will be after it's constructed. Right now this is being hosted live in GeoGebra's cloud storage, and we're able to share our worksheets using links generated by GeoGebra or embed code that is generated by GeoGebra. And we see that the student using this can change the measurements and the parameters of the problem. Notice the angle is changing dynamically as we adjust the height of the balloon, the distance of the observer, and now the student has the ability to solve for x. After they solve for x, they must add the height for the scope, and the combined sum of those two will give us the total height of the balloon, and then the student can click on the checkbox to see if they got the same answer, and hide it again, come up with a different configuration, and see if they're able to come up with the correct answer again. So it provides multiple opportunities for practice with the same problem just by changing the configuration of the problem. Here's the first image we'll be using. If you'd like, pause the video here, take a screenshot of the balloon, and you can have the same balloon in your activity that we have in the video. And the same here for the observer. You can pause the video, take a screenshot, and then your final product can look very similar to the one done in this presentation. We're going to use GeoGebra Classic because GeoGebra Classic works across all platforms. So if you're working on a MacBook, a Windows PC, a Chromebook, or a Linux machine, they all have access to the web, which means they can use the GeoGebra Classic app in the browser of their choice. When you first come to GeoGebra.org, I suggest signing in the top right corner. You can see my icon is there now because I'm signed in. That allows you to save your work to your GeoGebra cloud, and then click on this waffle to choose the applications. Again, we are using the GeoGebra Classic. It is the one that most resembles the desktop app that you can download and install. Once GeoGebra opens, the settings window is open. Click this X to close it so you can see your workspace. And then click on the workspace and click on this image icon or this graphics icon, and it will expand, and you can turn on your X and Y axes. You can turn on and off your background grid. We just want to turn on the axes right now. And then you click and drag the white space down so that the axes are lined up. I'm using the axes as rulers so that we can position things very specifically in our activity that we're creating. Now, these graphics tools will change dependent on what you're clicked on. Right now, we're clicked on the background, but if I were clicked on any type of a shape, like a point or a line, these options would change specific to points, lines, or whatever it is you're clicked onto at the moment. Here, the toolbar has the arrow tool, the point tool, the line tool, the special lines tool, the polygons tool, circles, conic sections, measuring tool, so it'll measure angles, segments, and so forth. We have our transformations tool and our special tools and just our moving option. So after each time you construct something, you should click on the arrow tool and click on move, just so that we're not constructing additional points or lines or whatever it is we're doing. It'll stop that so that we can just move around and explore the worksheet without creating things we don't want in the worksheet. And as always, I advocate to save your work often. We are working in a web app. It does not automatically save, so it's up to you to save. If you accidentally refresh your browser or close your browser, you would lose all of your work. So get into the habit of saving, especially once you've done something you found to be difficult. Save it so you don't lose it, and then you can move on and edit your worksheet further. So we're going to enter some points now to get started. All the way on the left side is your algebra pane, and your algebra pane has an input field, and we're going to type A equals parentheses 0, 0, and then press enter, and then we'll do B equals parentheses 10, 0, and then press enter, and it will plot your points for you. We see the points A and B are plotted. Once they are plotted, we are going to hide the X and Y axis. So click on the background and then toggle the axes so they're no longer visible. We don't want them to be in our worksheet. Again, we just use them to set up where our measuring guidelines will be. And now we have our A and B point, which tells us where our ground level will be for our activity. Next, let's put a line through A and B. We'll go to the line tool. The drop-down menu will choose the first option for a line tool, and then we will click on point A followed by point B, and we'll see the line as it's shown here. Notice the algebra pane, every time we construct something, it will give us an algebraic representation of it. In the end, we're going to hide this pane, but it's good to have visible as we're building everything. See these little circle buttons off to the left? That allows you to make each of these items visible or viewable. So if you want to just play with that right now, you can click this circle next to point A, and you'll see point A disappear from the screen. If you click that circle again, point A will become visible again. And that's true for any of the objects. You can toggle their ability to be viewed or not, or hidden, by toggling the circle to the left of their algebra definition. All right, so back to the input field in the algebra pane. We're going to add another point, C equals 1, 0, press enter. I'm going to use this point C as the launch point for the balloon. So the balloon is going to move vertically up and down over C to keep our activity consistent with where the balloon is launching from, and then we'll add other features and characters to the scene. So to keep the balloon on a straight path, we're going to put a perpendicular line through C. So we're going to go to the Special Lines tool, and then when the drop-down list comes, choose the option for perpendicular line. To define a perpendicular line, you need a point that it passes through and a line that it is perpendicular to. So you need to click on point C, followed by line AB, so it knows which point to pass through and which line to be perpendicular to. And order doesn't matter. You can click on line AB first and then point C second. It'll still have a point and a line to define what point it's passing through and what line it is perpendicular to. So now we have our perpendicular line on the workspace. And again, we're going to attach the balloon to this line so that it travels this straight path up and down over the launch point of C. So we want to insert a slider tool. The slider tool is going to control the balloon. So we see all the way down towards the right side of the toolbars, there's the Special Tools button, and the first option is the slider. Click on that. Once you click on the slide, let me go back a moment. Once you click on the slider option, click on a blank space that you want the slider to be anchored to in your workspace. We could always move this later, but once you click on that blank space, you will get this dialog box, which is asking you for the settings. And I changed the name to say H equals 0 for the height of the balloon is going to be h, and we're setting its initial value to 0. And then we're going to set a minimum. So the initial value and the minimum are different. So you can set the initial value to be 5 if you want. But we're going to set the minimum value to 0 and the maximum to 25, and we're going to increment by 0.1. We're going to choose the number option so that we have the option to use decimals. Integer would keep it obviously constricted to whole number increments. So we have the number option, 0 minimum, 25 max. You can always change these later, and you can even change the increment later if you choose. After you're done, press OK, and the slider bar will become visible. We see that it's horizontal. I want to change it to be a vertical bar. This way it'll be intuitive on how to move the balloon, because you're sliding a bar vertically and the balloon will be moving vertically. So let's do that now. Now we see our slider tool is in our workspace, and at this point I usually save my GeoGebra worksheets, especially when I'm working with GeoGebra in the web, because I find that when I insert a slider tool, if I don't save the worksheet, it's a little glitchy. So I'm going to come up to this menu bar. I'm going to click Save. I'm going to give our project a name. So I called it Hot Air Balloon Trig Worksheet. I'm going to hit Save. Down here I'm waiting for the box to tell me it's done saving. It says it saved successfully. Great. I will just test that my slider's working. Now, if you right click and drag or command click and drag, you can relocate the slider. If you do a quick right click or command click, we can choose the settings menu. And we come up to the tabs. In the slider tab is where we want to be. That's where the horizontal option can be changed to vertical. And back up in the tabs, I'm going to choose basic, give it a caption of height, and change my label to say caption and value. And now I will close the settings window. I should be able to command click and drag to relocate my slider tool, or right click and drag if you're on a Windows machine. I can drag my label to where I want it to be, and we're going to use this slider to move our hot air balloon picture once we have it embedded into our worksheet. Great, so now our slider is in the workspace. It is set up vertically. The next step is we're going to attach a point D to that slider, and that slider, when we move it, will move point D along the perpendicular line. So we can see we're going to go back to our input bar, and on the new input line, we're going to type D equals parentheses X parentheses C comma H. That means grab the X coordinate from point C, comma, grab the Y coordinate from H. If we look in the algebra pane, H is our slider tool, which we've renamed height with a caption, but H is the object. H will give the Y coordinate. And now I'll do a quick video showing how I set up point D with this definition and how it moves with the slider tool. We want to plot a point D that will traverse this perpendicular line. So we want the X coordinate of D to match that of point C, and we want the Y coordinate of D to be controlled by the slider. Notice our slider in the algebra panel is named H, and we're going to use that when we define point D. D is equal to parentheses X parentheses C, means grab the X coordinate of point C, close the parentheses, comma H means get the Y coordinate from the slider H, hit enter, and we see D is on the workspace, and if I grab my slider, we see that D traverses the perpendicular line. And now if I go all the way up, D is off of the scene. So what I'm going to do is take my mouse onto the white space of the GeoGebra worksheet and use the scroll on my mouse to zoom in and out. And then I'll click and drag to reposition my vertical line and my horizontal line down like this. And then I want to see if D still goes off the scene. It does not. So we can now use this layout for our interactive worksheet. The hot air balloon will be controlled by D so that its height will change according to the slider. We still have more to go. We'll add a surveyor and an angle of inclination to this as well, but we already have some interactivity in our worksheet. So we have our slider tool, we have point D connected to the slider tool, traversing the vertical line. Now we would like to plot a parallel line that passes through point D, but is parallel to point AB. So we go to our toolbar, we choose the special lines button, and the second option down is the parallel line option. Once we select that, you need to pick the point it will pass through and the line it will be parallel to. So click on D and then click on line AB, and we will have our parallel line that you see here. Now when you move your vertical slider, the whole parallel line will move up and down with point D. And the parallel line is so that we can stabilize the balloon image so it doesn't rotate or twist or enlarge or dilate or any of those things. The parallel line will keep it rigid in its motion. Once your parallel line is constructed, go to the menu button, hit save, save it with the same name that we did earlier, and that'll just save all of our work to this point. So as we move forward, we don't have to worry about losing anything we've done to now. Now we're ready to insert our first image. So once again, if we click on the Special Tools button, the third option down is Image. The dialog box opens, you'll hit Choose File. You'll follow your computer system's way of finding the file. So wherever you saved your hot air balloon image, you go to there and select it, and then you can click OK. We see that the balloon image shows up in the workspace, and see these two anchor points, E and F, showed up. So we want to anchor points E and F to that new horizontal parallel line, and that will, as long as E and F move with the balloon up and down, the balloon will not dilate and it will not rotate, and it will be a rigid motion up and down. So I'm going to add points to the parallel line. So we go up to the point tool, and one of the options from the drop-down list is point on an object. So we'll select that, and then we click the parallel line going through D on the left of point D and on the right of point D. And we're doing this without any specific definition, and that's going to allow us to slide points E and F on that line to resize the balloon once we anchor it. So we go to the input bar in the Algebra pane. We see now the input bar is at the bottom of the Algebra pane. As we keep creating objects, we'll just have to scroll down to get to the input bar. And inside the input bar, we're going to say E equals G. E is the left point of the balloon. G is the left point of D. And when we set them equal, it will move E and anchor it to G, and we'll still be able to slide G around to resize the balloon. Then after we hit enter, we'll type F equals H. So it'll take point F, it'll set it equal to H and lock it to H, and we'll be able to resize it from the right side also. We want to be able to resize it from the left and the right side so we can keep the balloon centered on point D. So we'll move a little bit on the left, a little bit on the right, get it bigger or smaller, keeping the basket centered at point D. So now that we've done that, I reposition the letters of my points. I drag E and G up and down, F and H up and down so that I can see them all. But we can now drag this point back and forth to resize the balloon and make it as large or as small as we want. But we do it on both sides to keep that basket centered at D. So I'm going to change the slider setting. I don't want the height to be visible there. That was just to help us set it up and see how the relationship between the numbers correspond to the line, but we wanted to just say height for the user because they are going to calculate the height. This is going to be a worksheet where they have to use their SOHCAHTOA skills to find that answer. So right click or command click on the slider, choose settings from the drop-down list, go to the basics tab up at the top. Once we get into settings, we'll go down to show label and change that to say caption. Once we're done, we'll hit this X to close the settings tab. So now you should be able to drag this slider tool, and when you do, your balloon will move vertically. Our points are all anchored. It's going to maintain its size. It's going to maintain its orientation. Part of our project is ready. We've got the height part. We're going to have to introduce the observer so that we can get an angle of inclination. So let's proceed with the steps to do that. As always, save your work. We've just accomplished a major part of the project. We don't want to lose it. Save it with the same name, or you can save it with a different version name if you want to be able to go back and redo things differently. If you didn't like how you did something, if you save it with a different name, that gives you the ability to do multiple versions of your worksheet. So now we're going to hide that vertical line. We don't want it to be viewed in our worksheet. So if you right click or command click, the available options say show object. If we just take that checkbox out from the show object, that vertical line will not be visible. And now when you slide your height tool, your balloon's going up and down without that vertical line being in the scene. And we're going to insert a segment right now. And if you go to the line tool, the second option down is segment. We're going to connect point D to point C. And it'll be a solid line at first, but click on the line, then click on the graphics button, and we're going to change this to be a red line, and then change the line type to be dashed. And this is going to be something that we will make visible when the person wants to see the answer. So this will be the height of the balloon. It'll have the height attached to it, but this will be something that can be toggled on and off by the user, so they'll be able to see if they got the correct answer. So now on our toolbar, we go to the angle picture because that's for measuring angles, but it also has measuring distance or length in the drop-down menu. We're going to choose that. Once you select that, you simply have to click on the segment you want to measure, and it will show up on the scene. Again, save your work. And we see that it says 10.5 next to the segment. So as you drag the slider up and down, this will change dynamically with the balloon height. And as I said, eventually we're going to put a checkbox to hide this so that when a student is doing this to try to calculate it, it will not be visible until they want to check their answer. We're also going to insert another slider. This slider will be a horizontal one, and the horizontal one will be to move the observer closer or further from the balloon launch. Once you click the place on the workspace that you want the slider to be, this dialog box shows up. We will set the minimum to 0, the maximum to 30, and increment to 0.1. We will name it D equals 0. This is saying the distance from the launch site is 0 initially, but the observer will move back. Now we see the horizontal slider is in place, and we will keep it horizontal because the observer will move horizontally, the balloon will move vertically, and this just adds to the intuitiveness of the interactivity with this sheet. We're also going to connect a point to this slider, and we're going to call it point X. So click on the input bar. If you don't see it, scroll down your algebra panel until you find it, and you'll type X equals parentheses D comma 0. The 0 will keep it on the AB line because that is at Y equals 0. And the D will attach point X to the slider for the horizontal distance. And now we're going to add a second point attached to X, and we'll call it Y. So go to your input panel, type Y equals, and notice it's a little x of capital X. The little x means grab the X coordinate of point X and add 2 units to it, comma, Y coordinate 0, and this keeps them 2 apart. We will attach the observer to these 2 points. Just like the balloon came in with 2 anchor points, the observer will come in with 2 anchor points. We'll attach them, and this will make the observer move and keep it a rigid motion. Next, click on the Special Tools button and choose the Insert Image again. This time navigate to where you saved your observer image. Click OK. The observer is in here. We see the observer is way too big, but once again, we will anchor point I, which is the left point, to X, which is the left point, and J to Y, and press Enter. So go to your input bar, I equals X, Enter, J equals Y, Enter. Now we see the observer is connected to those 2 points. And if you slide your horizontal bar, you should see your observer moving back and forth. Next, we want to put a point Z, which will be right at the observer's scope. This will be to create an angle of inclination from the observer's eyes to the base of the hot air balloon. So go to your input bar, Z equals the X coordinate of X, and these numbers in red, you'll have to fudge a little bit. So I did 0.8 that we were adding to the X coordinate and 2.3 that we were adding to the Y, and that was just to get Z to be centered and up. And you can try using different values here. Again, as you change to 0.8, that will move point Z left or right. And if you change different values of 2.3, that will move Z up and down. But you keep finding until it works for the image that you chose, that it's in a position that you feel works for the line of sight for the observer. We will go back to our special lines tool, choose parallel line, and we want to have a parallel line coming from point Z parallel to point line AB, so that it's the straight line of sight, the horizontal for the observer. Now that that horizontal line of sight is in there, we're going to go back to the points menu. So choose the point option, and 1, 2, 3, 4 down is the intersect, and you want to click on where the 2 lines intersect here, and that point will give us the distance from the observer's eyes to the bottom of the balloon. Once we have that point K in there, we don't need this horizontal line that's parallel to AB anymore. So right click on that line and choose the Show Object checkbox so it hides. And then we'll do the same for the parallel line going through point D. Right click on it, toggle the checkbox so it hides. So now those parallel lines are gone. We want to get rid of all of these extra points that are visible. So again, you can do this by right-clicking and toggling the checkbox, or you can go to your Algebra pane and find all of the circles next to each point and toggle them there. Now that all of those points are gone, we have this segment from K to Z that we're going to construct. Because we got rid of the horizontal line, we just want the segment. So we'll go to the Line tool, choose Segment, and connect K to Z. We'll do the same thing from Z to D for the angle of inclination that we will measure. Go to your Line tool, choose Segment, click point D and point Z. And right now we will enter a checkbox, and this will be to toggle the height of the balloon from D to C. So go to your Special Tools, choose Checkbox, pick an area of the workspace you want the checkbox to be in. Again, we can change that later with a command click and drag or a right click and drag. We can move any of those special objects off of the workspace. Once we click the white space for our checkbox, this dialog box shows up. We're going to type in the caption, show/hide balloon height. Again, this will be for the student to check their answer against the worksheet. And after that, this checkdown box lets you connect the checkbox to objects in your drawing. So when you click this gray list shows up. These are all of the objects we've created in our workspace, and we want to hide the segment CD. So we find segment CD, we click it, and it shows up in this box here. And you can put multiple items here connected to the checkbox and have them all hide when you toggle the checkbox. So now we see the checkbox is up here, and it says show/hide balloon height. If you click the checkbox, it should toggle CD and show or hide it. So right now it's hidden. We don't want it to be visible until after the student has done their calculations. Then they can check the box and say, oh, there it is, it's working. I see the answer, I can compare it to mine. Let's measure the angle of inclination. We'll go to the angle tool. That is the first one in the drop-down list. And you have to click the 3 points in the specific order to get the angle inside. So I have here, click the points D, then Z, then K. D, then Z, then K to get the interior. If you had clicked K, Z, then D, you would get an angle measure outside, which would be 360 minus whatever is inside of here. So if you ever get that, you come up to the undo button and then say, all right, I just have to click the points in the reverse order that I did, and D, then Z, then K will give you the internal angle measure. So at the beginning of this presentation, I said I'm not going to do everything quite perfectly. And right here is just an example of how we're going to finesse some of the settings we had earlier. When we look at this Surveyor, if I want to do this scenery in terms of feet, well, then the Surveyor's height was only 2.3 feet, and that wasn't a realistic height. So I'm going to change the height to be 5 feet. And simply, all you do is you go down your Algebra panel and you say, all right, let's make those points visible again that I need to adjust the height. So we're going to make the points X and Y and Z all visible so we can adjust the Surveyor's height. But before I did that, I said, let me set the point Z to where I want it to. And I simply changed the definition of point Z from X of X plus point A, comma Y of X. It was plus 0.23. We changed the point to 5 so that the Z went up higher. We said we want this to be the height of the person, 5 feet. And now we'll have to adjust the height of our image that follows. So to do that, we want to bring back the points X and Y because those were the anchor points we used for our observer. And we will adjust the values of points X and Y to get the observer to be tall enough to match up with point Z. And I adjusted point Z from being plus 0.08 to 1.5. I'll go back to previous scene. We see that Z was too much to the left. So when I was only plus 0.8, which you see right here, I said I need to shift it more to the right. Let's increase the X value. So I tried a few different values. I tried 1, 1.2. Eventually, I ended up settling with 1.5 because that brought it right in here. And I said that looks lined up. So that was just to show us how we can change things later when we realize that the height of the observer should have been more than 2.3 feet. Let's save our work here, and then we'll continue. Now that we have resized the observer in our scene, it only makes sense to resize the balloon. So if we go to the Algebra panel and find the points G and H, toggle the circles next to them to make those points visible again, because those were the points we anchored the balloon to. You can drag G and H further out from D to make the hot air balloon larger. And just make sure you do it equally on both sides to keep the basket centered over D. Once you're satisfied with the balloon size, go back and toggle G and H again so they're no longer visible. Next, we'd like to change the line of sight to be a dashed blue line. Click on the segment, go to the top right corner, click the graphics option so it expands the menu, choose the color blue, and then select the line style and make it dashed. Do that again for the other segment. Now we would like to add a measuring markup by the observer because the student will need that information to solve the problem. So if we scroll through the Algebra panel, we can find point Y, make it visible by toggling the circle next to it. We're going to add points W, V, and U to this part of the image. So scroll down the Algebra panel until you find the input bar, type W equals x of y plus 5 comma 0, hit enter, then v equals x of w comma y of z, then hit enter, and I forgot to put u in here, equals x of v minus 1, and then y of v, and then press enter. That will give us these 3 points. We will connect these 3 points using segments. Go to the line toolbar, choose the second option which says segment, click point W, then V, then click V and point U. We have these 2 segments in. We would like to put a label on this segment, the vertical segment, so we're going to right click on WV, choose settings. Once the settings window opens, make sure you are in the basic tab, go down to caption, type scope equals 5 feet, and then below there where it says show label, click the drop down and change it from caption plus value to caption only. Now we see that this measuring markup says scope equals 5 feet. That is a piece of information the student will need when solving for the height of the balloon over the ground. So in this frame, we're going to hide points U, W, V, and Y. You can right-click on each point and toggle the Show Object checkbox, or you can find each of these points in the Algebra pane and toggle the circle next to the point name. Next, we will do another measuring markup that will handle the distance between points K and D. So to do this, we're going to add 4 points here. We're using D as a reference. So in your Algebra panel, scroll to the bottom, find the input bar, type Q equals x of D minus 4, comma, y of D. So that will give us a 0.4 units to the left of D, but with the same y coordinate as D. Then point R, we're going to use Q as its reference, so it'll be the same x coordinate as Q minus 1 with the same y coordinate as Q, so they are horizontally level. Point S will be vertically below point R, so we're going to say use the same x coordinate as R, so it's x of R, comma, y of K, because we want it to be the same height as K. And then point T will have the same x coordinate as Q, the same y coordinate as K. Press enter, and we have these 4 points. Once again, we go to our line toolbar. The second option is segment. We will create a segment from Q to R, then from R to S, then from S to T. Once we have this line segments in place, we will hide points Q, R, S, and T. And next we will set a caption that will represent the distance from D to K. So we will right click on the vertical segment again, go to settings. When you're in settings, make sure you're at the basic tab, go to caption and just type in a lowercase x, go down to show label and change it from caption plus value to just caption. Now we see we have an X that represents the distance, and we're going to hide the points K and D, which were beneath the balloon, point Z, which was at the scope, and point C, which was on the ground beneath the balloon. And after we hide all those points, we have this clean scenery that you see here. You can move the height slider vertically to make the balloon move up and down, and you should see the span for X grow and shrink with that. And you can move the slider for D, which moves the observer horizontally, and the scope should stay an equidistant from the observer as the observer moves. So it should stay 4 units away as you move back and forth. Now we're going to hide the Algebra menu, and it's up there in the top right corner. You have those 3 horizontal bars. Once you click that, you can go to the View menu, and then the Algebra menu has a checkbox. Remove the check, and the Algebra panel will disappear. If you want to bring it back, you just go to the menu option, View, and Algebra panel to bring it back if you need to get back to it to access points or lines so you can edit something. So now I would like to add to the landscape of the scene that we've set here. I would like to set the base to be a green for the grass that he's standing on. And to do this, I'm going to use my mouse to scroll out as a zoom, and then I'll click and drag, and I'm going to go to the polygon tool. I'm going to draw a quadrilateral. I'll click at the far left, the far right, move close to vertically down. It doesn't have to be exact. None of this will be visible in our final product anyway. Once I've done all 4 points, you have to click the starting point to close the polygon, click the mouse tool, select the polygon, and now we come over to the graphics bar, change the color to green, and now we have our green grass. I'll drag this down, I'll zoom back in, drag and reposition, and zoom, drag and reposition. So this looks good. Now I'm thinking about, I want to be able to embed this into a website. So I'm going to make it a little bit smaller, and I'm going to use the left side of my browser as my guide. And I want to make sure that when the observer is all the way back, I don't cut off this part of it in my browser. So I'm going to resize my browser to keep this visible. That looks like a good size. I'll bring the bottom up. And this is a nice small browser window. And I can reposition my special tools here. 2-finger click and drag to reposition the height. 2-finger click and drag to reposition the distance. And I don't want the observer at the far end. I don't want the height at any of the extremes. This is a good initial view for when a student sees the worksheet. And I'm just testing, everything seems to work. I can reposition my show the balloon height checkbox. Again, 2-finger click and drag, and this looks like a good setup. So I'm going to save this. I have my green grass. I have everything laid out in the position I want. My initial values are not at any of the extremes. Menu, File, Save, use the same name, click Save. I'm waiting for the indication that the save was successful. It says save successfully. You can now share this worksheet right from here. You can click the share, or I like to go to my GeoGebra homepage. When you're logged in, you click on your icon and it brings you to all of the stuff you've created. Right here you see the hot air balloon worksheet that we just made. Click the 3 buttons, go to Details, and then go to Share and Embed. So now I can get this version of the share. Now the difference between the 2 versions of the share is, notice that this does not have the GeoGebra toolbar on top. I don't want students to be able to edit or add figures to it, just interact with it. Where if you shared it right from here, you would be getting the toolbar students can add to the drawing. It was just to keep it a simple, streamlined version. That's why I'm using this. This is the activity share, and this is the construction share. So those are the differences in the shares. So there's a final detail I have to add, and that is the horizontal line. We want to add a label to that. So right click on that, choose Settings from the drop-down menu. When the settings open, click on the Basic tab, go to Caption, type Distance, then go down to the Show Label option and choose the drop-down box and make sure it has Caption and Value. So it'll say distance equals, and it'll show the distance the observer is from the launch pad, and that's an important piece of information so students can calculate the vertical height. And now you should see the distance equals 19.7. Whatever that number is comes from our horizontal slider. So we're going to change our horizontal slider to not show the number anymore. We'll right click on that, click on Settings, and change the settings to just Caption and have the caption read distance. So in the end, you should have an image that looks like this. The horizontal slider says distance, but the distance is being shown on the horizontal line of sight. And as you slide the horizontal slider, that number should change. As you slide the vertical slider, the balloon should move and the angle of inclination should change. All of the information a student needs to calculate x is here, and they would add their answer for x to the scope height of 5, and their final answer should match what shows up from the checkbox for the balloon height, and they can keep changing the orientation and practicing the skill. I hope you liked this video and the presentation. I hope the tutorial taught you much about how to use GeoGebra. I gave you some of my styles of how I use it to create interactive worksheets for my students. I embed these into my learning management system or into my Google Sites. You can get more of my tutorials at www.mrhudak.com. You can reach my YouTube channel there, my GeoGebra channel, and my other sites such as my educational technology sites that I'm putting together. All right, thank you.